Imagine a world transformed in an instant by the blinding flash of nuclear fire. Cities vanish beneath mushroom clouds, landscapes are scarred by radiation, and the familiar rhythms of life are shattered. Throughout history, the specter of nuclear apocalypse has haunted our collective imagination, captured in haunting archival images and chilling reconstructions. In the aftermath of such devastation, the fate of every living creature hangs in the balance. But amidst the ruins, one question emerges. Could pigeons, those resilient urban survivors, endure the unthinkable and find a way to persist? When a nuclear detonation occurs, the environment is subjected to intense and immediate devastation. The explosion generates a powerful blast wave that flattens structures, uproots trees, and drastically alters the landscape. Intense radiation is released, causing severe harm or death to living organisms within the affected area. Fallout, consisting of radioactive particles, spreads through the air and settles on the ground, contaminating soil and water sources. In the aftermath, wildlife faces acute challenges such as lethal radiation exposure, loss of habitat, and scarcity of uncontaminated food and water. In the wake of nuclear events at Hiroshima, Nagasaki, Chernobyl, and Bikini Atoll, the devastation to both human and natural environments was profound. Yet, in these seemingly inhospitable landscapes, nature has shown remarkable resilience. Birds, in particular, have surprised researchers by returning to these areas, sometimes within just a few years of the disasters. At Chernobyl, for example, a variety of bird species have been observed nesting and foraging despite ongoing radiation. These unexpected recoveries highlight the adaptability of wildlife, even in the face of extreme environmental challenges. Pigeons, due to their small size, are biologically more vulnerable to certain environmental hazards, including radiation. Their compact bodies mean that harmful substances can penetrate tissues more quickly and reach critical organs with less exposure compared to larger animals. As a result, pigeons require a lower dose of radiation to reach fatal levels, making them more susceptible to radiation-induced damage. In contrast, larger animals have more body mass to absorb and distribute radiation, often requiring higher doses to experience similar effects. This heightened sensitivity in pigeons highlights the importance of considering species-specific vulnerabilities in environmental and biological studies. Pigeons possess a notably rapid metabolic rate, which means their bodies process energy and nutrients at a swift pace. This heightened metabolism can accelerate cellular repair mechanisms, allowing damaged tissues to recover more quickly. Additionally, a faster metabolic rate increases the rate of cellular turnover, which may lead to a higher frequency of genetic mutations. In contaminated environments, this combination of rapid repair and mutation could provide pigeons with an adaptive advantage, enabling them to cope with and survive exposure to various pollutants more effectively than slower metabolizing species. Pigeons are remarkably adaptable creatures, thriving in urban environments around the world. They have developed a unique resilience to pollution and toxins, allowing them to survive in cities where air quality and food sources can be compromised. This adaptability extends to their ability to find shelter and resources in even the most challenging conditions. Such traits suggest that pigeons could be well prepared to endure drastic changes, including those found in post-apocalyptic scenarios. Pigeons are renowned for their extraordinary navigation abilities, which allow them to travel vast distances and return home with remarkable accuracy. Scientists believe that pigeons use a combination of visual landmarks, the Earth's magnetic field, and even the position of the sun to orient themselves. In the aftermath of a nuclear event, these skills could prove invaluable. Pigeons might be able to sense and avoid contaminated zones, seeking out safer habitats where radiation levels are lower. This natural instinct for survival could help them adapt to challenging environments and find new areas to thrive. Pigeons are often compared to other remarkably resilient creatures, such as cockroaches and tardigrades. While cockroaches are known for their ability to withstand high levels of radiation, and tardigrades can survive extreme temperatures and even the vacuum of space, Pigeons do not possess these extraordinary superpowers. However, pigeons have their own unique set of advantages. Their adaptability to urban environments, impressive navigation skills, and ability to thrive alongside humans make them stand out in their own right. Unlike their microscopic or insect counterparts, pigeons demonstrate resilience through intelligence and versatility rather than sheer biological toughness. It's an uncomfortable truth that pigeons may not endure due to any remarkable biological advantage. Instead, their survival often hinges on their ability to fly, enabling them to quickly escape dangerous blast zones. This mobility allows pigeons to relocate to cleaner, safer areas when their environment becomes hazardous. Their resilience, therefore, is less about inherent toughness and more about the opportunities their wings provide. The survival of pigeons in a nuclear apocalypse challenges our assumptions about what it takes to endure extreme conditions. Rather than relying solely on biological resistance to radiation, these birds demonstrate that mobility and adaptability can be even more crucial. Their ability to move quickly, find new food sources, and adjust to changing environments gives them a distinct advantage. This realization is unsettling, as it suggests that success in the face of catastrophe may depend less on inherent toughness and more on the capacity to adapt and escape. Ultimately, the story of the pigeon serves as a reminder of the unpredictable nature of survival in a transformed world.